Right, as advertised, the next thing I want to do is show you quantitatively how you would add A and B here to give you the components of vector C or the magnitude and direction of vector C. And the way I want to do that is by adding them in component-based methods. So maybe the first thing I should do is explain the procedure for how to add vectors in component-based method, because this is going to be something that's really fundamental and really important throughout the whole course. So how to add vectors in component form. Okay, step one, well, obviously the first thing you need to do is obtain the components of all the vectors you are adding. So you're going to do that using the procedure that we developed over the past few videos. Draw the right triangle, use the trigonometry, get all the components of all the vectors that are involved so that you have all the x components and all the y components. Okay. The next thing you want to do is basically organize the components into their x and y categories. So basically, grab what happened to my window. There we go. So number two, what you want to then do is add up all the x components. And then you want to separately add up all the y components. And so when you add up all the x components, this is going to be equal to the x component of the answer. And when you add up all the y components, this is going to be equal to the y component of the answer. And it's just that simple. It's just that simple. People make this hard, but it's actually not hard at all. You just break everything into x and y components, completely separate them from each other, and then add all the x in one column, add all the y in another column, and then you have your two answers. Because remember, there's actually two answers when you're trying to obtain a vector, because vectors have two pieces of information involved in them. Okay. So let's do it. Let's do it. Back to this. Okay. So, step one. Vector A and vector B here have been given to us in magnitude and direction representation. So the first thing we need to do is obtain the components. As discussed in previous video, the way we do that is we turn these into right triangles. So I'll draw a vector like this. I'll draw a line like this and like this to get a triangle for this guy. And I'll draw a triangle like this for B. So that line is a little off. There we go, something like that. Okay. So this side is going to be AX. This side is going to be AY. This side is going to be BY. This side is going to be BX. Okay, so what I want to do, and this is my biggest piece of advice on this kind of stuff, and you're going to see this again and again and again and again for a long time in the course. Once you start separating out X and Y, keep them separated. So I'm going to have an X column over here with all the X information, a Y column over here with all the Y information, and X and Y are never going to mix here. I'm going to separate them, put them in two columns, and then from that point on, I'm solving two different problems, and X and Y never talk to each other. Okay, so anyways, we've got AX. Let's find that first, AX. So first of all, is it positive or negative? It's negative because that vector points to the left. So I should have a negative sign in front of it. The magnitude is 4. And what's my trig function? I see that X is adjacent to the 35-degree angle. So this is going to be cosine of 35. Okay, let's do AY. So AY is positive because the vector points upwards. We've got 4 meters here. And then AY is opposite of the 35-degree angle. So we'll have sine of 35. All right, then we've got BX. Is it positive or negative? It's positive because that vector points to the right. The magnitude is 5. And in this case, BX is opposite of the 60-degree angle because it's opposite there. So that'll be sine of 60. And for BY, we'll have that one is positive, 5, and that's going to be cosine of 60. All right, and let me crunch all these numbers. Cosine of 35 times 4. So this is negative 3.28, and these are all in meters. Sine of 60 times 5 is positive 4.33. Then over here, sine of 35 times 4 is 2.29. And cosine of 60 times 5 is 2.5. All right, now I've got, so that was step 1. Now I've got all my X components and all my Y components. Next thing I do, the X component of C, remember C is the sum, C equals A plus B. So the X component of the answer is just the sum of the 2 X components. And when I say sum, you do include that negative sign. So it's actually a subtraction in this case. So it's going to be 4.33 minus 3.28, which is 1.05 positive. And then over here, 2.29 plus 2.5 is 4.79. So there's my 2 components. So as I predicted in the geometry video, the X component is pretty small and the Y component is much larger than the X component. So it points almost in the plus Y direction, as I was expecting from the geometrical argument. So these are the 2 components of the answer. Then you have to see what's the question actually asking for. Is it asking for the components of C, or is it asking for the magnitude and direction of C? If it's asking for the components of C, you're done. If it's asking for the magnitude and direction of C, then you have one last step to do. You need to go back to previous concept that we did. We have now a vector C whose components are given. How do we get its magnitude and direction? And the answer is draw a right triangle. So we have a right triangle here. It's going to look something like this. It has both components positive. So vector C is going to point up and right. The Y component is much bigger than the X component. And let's solve for this angle here, let's say. So I'm going to have magnitude of C equals square root 1.05 square plus 4.79 square, which is plus 1.05 square, square rooted 4.90. And that angle theta, let's do it as inverse tangent of, it's going to be y over x, opposite over adjacent. So 4.79 over 1.05. 1.05 inverse tan. And I got 77.6. and that's 77.6 counterclockwise from the positive x-axis. Okay, and so there's the magnitude and direction of my answer. So important things here. You cannot directly add the magnitudes of vectors. You cannot directly add the magnitudes of vectors. You have to break them into components first. Then you can add the components. So do not try to, like, if I gave this problem on a test, some students would just be like, oh, easy, 4 plus 5 equals 9, done. Because A equals 4, B equals 5, A plus B equals 9. But you can see this is totally wrong. It's not even close to being the right answer, and it completely misses the point of what we're doing. You've got to actually go through the procedure of how to add these vectors to each other. So make sure you master this procedure of how to add vectors. You'll get a lot of practice of it over the coming weeks.